Hello everyone. Today I'm going to talk about 5G. 5G is the fifth generation of wireless data networks, and it will improve the overall speed far more than 4G or 3G ever could. You'll feel it in your phone, your home, your car, around the city and town. Downloads and streaming should happen literally without a noticeable delay. Cars will talk to each other to prevent collisions, and not to mention industrial benefits like remote surgery or drone control. Now we will see how everything works like a magic. The first component of 5G I want to talk about is its architecture. In a given square kilometer, 4G could only manage to connect about 1/10 of the amount of devices as 5G can, if that's some of what 5G does. This is achieved using three keys. 5G uses a new radio technology, the part of any wireless device that makes the connection. 5G uses some at sub-6, which is from 600 MHz to 6 GHz. Part of this band is also used by current 4G LTE. The 5G will also use a higher band of radio frequencies from 24 GHz to as high as 86. These much higher frequencies can then allow higher data rates. Now, while these 5G radio waves can carry more data with higher performance, they can't carry it over a long distance, so 5G will use a lot of so-called small cells. These are small versions of big cellular towers which we have seen. 5G will also use some new technologies in these small cells like beamforming to aim for higher transmission efficiency. To access the new 5G network, you will need new phones, tablets, portable hotspot and such, which has a 5G gear inside. Otherwise, the current 4G or even 3G gears cannot satisfy the hardware requirements of 5G. 5G networks will also position more data and computing resources closer to you, which can avoid blunting 5G's low latency benefits. Here is a core level where 5G is different from 4G. Among the myriad of architectural changes which accompany the shift from 4G to 5G, including the migration to millimeter wave, massive MIMO, network slicing, and essentially every other discrete element of the 5G ecosystem. The 4G evolved packet core is significantly different from the 5G core, with the 5G core leveraging virtualization and cloud-native software design at unprecedented levels. The changes that differentiate 5G core from 4G core are UPF and AMF. The functionality of UPF, or in other words, user plane function, is to decouple packet gateway control, and the functionality of AMF, the access and mobility management function, is to separate functions from connection and mobility management tasks. In order to bridge the gap between 4G and 5G, it will require incremental steps and well-orchestrated game plan. Emblematic of this shift will be the gradual transition from non-standalone mode to standalone mode 5G architecture options. The 5G non-standalone standard was finalized in late 2017 and utilizes existing LTE radio access network and core networks as an anchor, with the addition of a 5G component carrier. Despite the reliance on existing architecture, non-standalone mode will increase bandwidth by tapping into millimeter wave frequencies. Having introduced the architecture, the next component I'll discuss is 5G applications. When we transformed from 3G to 4G, lots of new applications had emerged and changed the ways people live. Just like 4G, as 5G is gradually stepping into everyone's life, it has driven the industry to think about what are some potential applications which can benefit from 5G. So to gain some insights, we first need to define the key characteristics of 5G which directly impact the user and the applications. In simple terms, 5G will provide wireless connection which has lower latency, greater speeds, and more capacity. Having this in mind, let's have a look at some of the most discussed applications which people think 5G will impact. The first one is AR and VR. These two technologies are set to benefit from 5G because those heavy computations can be done remotely on the cloud, which is otherwise not feasible in the local machines. However, since VR is largely used in stationary environments, and the high-speed connectivity can also be achieved using wired connection, 5G is not likely to have a large impact on the development of VR. On the contrary, 5G will play a critical role for AR because AR is largely a mobile activity, and AR will require lots of processing on live imagery and environment, and therefore can benefit from mobile cloud computing. The next application is autonomous vehicles. It can also integrate with 5G, so that the communication between vehicle to cloud and vehicle to vehicle can be realized. However, considering the limited coverage of the 5G signals under the current atmosphere, it's unreliable to depend on the cloud for safety-critical decisions. On the other hand, 5G has made it possible to provide an immersive media experience inside the vehicles, which has made the traveling much more entertaining. The final application I want to talk about is mobile games. This is a domain which can be greatly enhanced using 5G. The high speed and low latency provided by 5G allow the mobile devices to delegate those heavy processing tasks to the cloud, and the cloud can then pass back the results. This can make it possible for those mobile game developers to create games which require a higher processing power which is not feasible by mobile devices. Eventually, this can lead up to a higher quality gaming experience. After talking about the applications, the next thing I want to highlight is a challenge. It's a new technology. 5G has left plenty of space for imagination, but we also have to face the challenges which come along with it. The first challenge is with the signal range. 5G is known for its high-speed connectivity, but there is also a trade-off from its speed. The range of signal is much lower than 4G and previous generations. As a result, it will require much more antennas and base stations to be built to achieve the signal coverage. This is not that much of a challenge inside the urban area, since the population is quite dense and the demand for networks is high. However, in the rural areas with much less population, it becomes too costly to achieve the same amount of signal coverage as in the urban areas. Another challenge for 5G is its cost. To provide 5G services, those network providers will need to upgrade their infrastructure to meet the requirements of 5G. As a result, it's very likely that the network providers will charge the users a higher fee to achieve a cost-profit balance in the next few years. The last challenge is regarding the 5G use cases. Although people have been discussing all sorts of applications that are made possible using 5G, for the general public to really transform from 4G to its next generation, there still misses those killer applications which can drive everyone crazy to upgrade to 5G. In conclusion, 5G is believed to be the next generation technology that will reform the ways people interact with the internet. However, to reach the destination, there are still lots of challenges to be overcome. Thanks for watching.